Okay, hello and welcome back to Mr. Leader's Cutting Edge Math channel. We're going to continue with this lesson on sections 10-1 till 10-3. So the first thing we're going to look at is the Lance problem. And, if you were here yesterday, some of you got to hear about the Lance problem. If not, then here it is. So anyway, Lance can ride his bike 60 miles with the wind in 2 hours. And so what you want to do is, on the return trip, the same distance takes him 2.5 hours. 2 hours and 2.5 hours. So what you want to do is set up two things. Let x equal, first you should see what the question is. How fast is the wind blowing? And what is Lance's speed without the wind? So those two things should be your variables. And so what you want to do probably is let x equal Lance's speed, Lance in still air, and then let w equal, it should be say speed, let w equal speed of the wind. It should say speed of Lance. Speed of Lance and speed of wind. Okay, and this problem is pretty simple because generally use the equation rate times time equals distance, but in this case the rate with the wind would be x plus w, and that's going with the wind, I guess, and then times 2 hours is the time equals 60 miles, and going against the wind with, and this is against, I have another equation for against the wind, and that's going to look like x minus w, because the wind's pushing him, slowing him down, and that takes him 2.5 hours to go the same distance. Now to solve this system, some of you guys probably want to distribute and then use elimination or substitution, but it's easier in this case if you just divide both sides by 2 and on this equation, and divide this equation by 2.5 on both sides. And in that case, what nicely happens is those things go away, and the first equation turns into x plus w equals 30, and the second equation turns into x minus w equals 24. And now it becomes much easier. I mean, this one's set up to work out, but that's okay. And then you add those two equations together, elimination method, 2x equals 54, so x equals 27, so that's Lance's speed with the wind, and since you know that x plus w equals 30 is the wind speed, or that's his speed in still air, and w, therefore the wind speed would have to be 3, right? Which makes sense, because 27 plus 3 is 30, and 27 minus 3 is 24. There you go. Okay, next thing. Okay, so the next thing we're going to learn how to do is how to solve equations with systems of equations with matrices. And basically what this little formula says is that if you multiply the constant matrix, which is this one over here, 8, 23, 53, by the inverse of what is called the coefficient matrix, you will get x, y, and z. Now you kind of, it would be good to know why you're doing this, so I'm going to tell you a little bit about why. So in this case, say you have this system of equations right here. This system of equations can be written with matrices as 1 minus 2 minus 1 times 2 minus 3 plus 1. I'm taking the coefficients of each of these equations. 4 minus 5 plus 5 times, so if I take this matrix and multiply it by x, y, and z. Okay, if I multiply this times this, the way you multiply matrices, you take this row, multiply by this column. Okay, and then you take this row and multiply by this column, and take this row and turn it sideways and multiply it by this column. And that would have to equal to what's on the right side of the equation, which is 8, 23, and 53, right? And so now the reason that this works up here is because if I multiply by what's known as the inverse matrix of this thing, basically what you're doing is you're multiplying by 1. And so this side of the equation, well, if you multiply by the inverse, you're going to get 1 over here, which it's really, you get the identity matrix, which is zeros and ones. It's like a 0, 0, 0, or 1, 0, 0, 0, 1, 0, 0, 0, 1. If you multiply this times this, you get 1. And if you multiply that side by the inverse matrix, you have to multiply this side by the inverse matrix of this thing. So if I call this matrix A, and this is A inverse, then I have to multiply that side by A inverse as well. So that's basically where this formula right here comes from. Now, how do you find an inverse matrix? It's a very complicated, long process, which probably in college or something you'll learn how to do by hand. And in previous classes we've taught how to do it by hand, but it's a real pain in the neck, so your calculator can do that for you. So if I were going to do this with my calculator, the way I set that up is by going to my calculator and always in front, and I'm going to go over here. So what I'm going to do is I'm going to multiply the inverse of this matrix times this thing called the constant matrix, and that's going to give me my x, y, and z. So I'm going to clear, that's my program from yesterday, and the way you do that is you go into your matrices, which are here, second matrix, and we're going to get A up there, okay? And matrix A, whoops, second, sorry about that, I have to edit my matrix. So second matrix, I need to edit matrix A. So you hit enter, and if it's not a 3 by 3, which is what you want, you have to change those numbers to a 3 by 3 matrix, meaning 3 rows and 3 columns, and then you just go down here and you put in those numbers right here. So I go 1, enter, -2, enter, -1, and just keep clicking away. Okay, so there's matrix A. Then I have to put in the constant matrix over here, which I'm going to call matrix B. So I'm going to go second, I'm going to quit out of here, and I'm going to go second matrix, and I'm going to go down to B, and I'm going to edit that one. Okay, and I want that one to be a 3 by 1 matrix. Okay, so I'm going to edit it, and so it's 3 rows by 1 column. Or is that a 1 by 3? We'll see in a minute. 3 by 1, and if I hit enter, there we go, that's a 3 by 1 matrix. And then I go down here and I put in those numbers, 8, enter, 23, enter, and 53, enter, and then I go second quit. So then all I have to do to find my answer is multiply the inverse of matrix A times matrix B. So I'm going to go to second matrix A, and I'm going to get the inverse of that. And the way you go the inverse of that is I just hit that x to the -1 button, okay, times matrix B. So I'm going to go second matrix B, which is down here at 2, okay, and so what has to happen with a matrix, if this is a 3 by 3 and this is a 3 by 1, the number of columns in this one has to match the rows in this one, otherwise you're going to get an error. And then if you hit enter, you get singular math error, and which means so to continue here, I didn't make a mistake. I put everything in right, and I set up my matrices correctly. But what happens sometimes, or a lot of the times, is that a matrix doesn't have an inverse. One cannot be found. So in other words, there's no matrix that I can multiply this one by to get a matrix with ones on the diagonal and zeros everywhere else. And so this one has no solution. So this system of equations, which is often the case, system of 3 equations, remember those are 3 planes in space, they don't intersect at a single point. So that is why we got an error, not because I did the math wrong. Alright, but the next problem does have a solution, so we're going to go to that one now, if I can find it. Alright, so view in front, where'd my work go? Okie doke. Alright, so we're going to go to this next problem, and you will have something like this on a test, so it'll probably be a good idea to know how to do it and set one up like this. So a dietitian wants a patient to have a meal that has 65 grams of protein, 95 grams of carbs, 905 grams of calcium. Food service tells the dietitian that for dinner today is chicken potatoes and 2% milk. Each serving of chicken, oh, does this look complicated? Each serving of chicken has 30 grams of protein, 35 grams of carbohydrates, and 200 milligrams of calcium. A milligram is 1,000th of a gram, right? And he served 4 grams of protein, 33 grams, and 10 milligrams of calcium, and so on and so forth. So the way that you set this one up is like so. Where'd my mobile board go? Okay, so what you're going to do is so over here on the right side of your system, you're going to have this system where on the right side you're going to have your limits of your, so for your protein, your carbohydrates, and your calcium. So over here you have 65 milligrams, and that's 65 for the first equation. Chicken has the food service, every serving of chicken has 30 grams of protein. Okay, so you're going to have 30. We want to add up to, we want to find the protein equation. So here's your protein equation, and you have for chicken, you have 30 grams for chicken. And then for what's next? Then for baked potatoes, it only has 4 grams of protein. 4 for potatoes. And then for your milk, it has 9 grams of protein. like this. Okay, so there's your first equation, and then your next equation is your carbs equation. And chicken has 35 grams of carbohydrates. Baked potatoes have a lot of carbohydrates. Ooh, less than chicken. Look at that, 33 grams. And each glass of milk has 13 grams of carbohydrates, and your carbohydrates have to add up to 95 grams altogether. Okay? And then for your calcium equation, this one's in milligrams, but everything else is in milligrams as well, right? So over here you have chicken has 200 milligrams of chicken. Oops, sorry, I shouldn't have had G's there, should I have? Okay, I should have had I'm messed up. This is milk. This is chicken, potatoes, milk. Okay, this is 200 milligrams of calcium for chicken. See, this is why it gets very confusing. And then you have 10 milligrams in your potatoes, and then you have lots of milligrams of calcium in your milk. Okay, and that should add up to a total of 905 up there. Alright, so now you go back to your matrices and you put those numbers. This is your coefficient matrices, so this is like your A and this is like your B. So we're just going to get our calculator again, if we can find it. There it is, and we're going to plug in those numbers into our matrices, and it should already be set up from the previous problem. Okay, so that get rid of this thing, move this, and then we're just going to put, oh my god, we're going to put, I don't know where things keep going. Let's try that again. Sorry. Okay, so let's see if we could go back to where I was. Probably not. There we go. And when I move this thing, is everything gonna disappear again? No, it's not. Yay. Okay, so now I'm gonna put in these numbers into my matrix A. So second matrix A, and I want to edit matrix A, so I go over to edit, I hit enter, and then it's a 3 by 3, and I just go in here and I put those numbers 30, okay, 4, 9, 35, 33, 13, 200, 10, 300. Okay, make sure you hit enter when you're done. Okay, then I'm going to go second quit, and I'm going to go to second matrix, and I'm going to go to edit matrix B. So I'm going to go down, and then I'm going to put in those three numbers. I'm already at a 3 by 1. So I'm going to go in here and go 65, 95, and 905. Alright, and there's my matrix B, and I'm going to go second quit. So what I want to do is multiply the inverse of matrix A. So I'm going to go second matrix A, and I'm going to hit inverse times matrix B. second matrix B, and hopefully it's not going to give me an error again. I hit enter and I get a nice answer. So what this means is A, B, and C, in other words C, P, and M. I want to take 1.5 grams of chicken, 0.5 grams of potatoes, and 2 grams of milk to make my meal. Okay, and I think that the milk should be in 2 grams, which would be 2,000. No, and 2 grams. 2 grams of 2 grams of milk. Okay. How many? Oh, it's 2 servings. I'm sorry. 1.5 servings. Sorry. 1.5 servings of chicken, 0.5 servings of potatoes, and 2 servings of milk to have your balanced meal. Okay. So I'm not sure that dietitians would use matrices, but maybe they would. And your homework is at the end of this sheet, which you can finish up. And remember, you heard it here on Mr. Leader's Cutting Edge YouTube channel. Goodbye.